Bismillahirrahmanirrahim. Today we are going to speak about the scatter plot and correlations and coefficients of correlation. Scatter plot and correlation. The scatter plot is a graph of the ordered pairs x and y. We have two variables x and y. These will represent pairs and can be graphed by just putting points in the ordered pairs of numbers. So it is scatter plot is a graph of the ordered pairs xy of numbers consisting of the independent variable x and the dependent variable y. For any relation, for any function, we have two variables, x and y, and a linear function. X, we call it independent, because we can choose any value for x, but y will be the output of using the independent value of x. Just to be, if I have y equal to x minus 1, this is a linear function, x and y. For x, we can choose any value, let's say 1 or 0, 1, 2. These are independent, it can be chosen randomly. But y, we cannot choose it. Y will be the output of the equation. I have to substitute x by 0, so it will be minus 1. If I put 1, it will be 0. If it is 2, it will be 1. So we call x the independent variable and y is the dependent, the output of the equation. And these two, x and y, will give me ordered pairs, x, y. For the correlation, the population correlation coefficient denoted by the Greek letter rho is the correlation computed by using all possible pairs of data values x, y taken from the population. We have formula for finding the value of the correlation or coefficient of correlation. The linear correlation coefficient computed from the sample data, this is sample data, measure the strength and direction of a linear relationship between two quantitative variables. I have x and I have y. We need to find the relation between x and y. Is it linear or not linear? Is it strong or not? When we are doing some statistical study, we are choosing some variables or input and check the outputs. Let's say, for example, the relation between the score of the students and number of questions in the exam, or scores of the students and number of absences. Is there any relation between these? The absences of the student and his score in the final exam. To find the relation, we have to find the correlation and see do we have a good relation or strong relation between this or not. The symbol for the sample correlation coefficient is R. The range for the correlation coefficient is from -1 to +1. So -1 less than or equal to R, less than or equal to +1. If we have -1, it means that the relation between x and y is negative. It means that when we increase x, y will be decreased. If it is positive, it means that increasing x will increase the output y. So we have negative and we have positive correlations. For this, we have some properties for the linear correlation coefficient. We said that the correlation coefficient is a unitless measure. There is no unit for this one. It is not centimeter, it is not kilogram, it is not distance units. The value of R will always be between -1 and +1. We said -1 is negative relation or correlation, +1 is positive correlation. If the value of x and y are interchanged, the value of R will be unchanged. If we reverse the order between x and y, R will be the same. There is no change for R. If the values of x and or y are converted to a different scale, the value of R will be unchanged also. If we change the scale from kilometers to meters, for example, or from kilogram to grams, from kilogram to grams, in that case, the unit of R will be unchanged. The value of R is sensitive to outliers and can change dramatically if they are present in the data. Sometimes some input from or outliers, and some input which are not related to the experiment. For some reason, if they exist there, this will affect the value of R. Now, to find the linear correlation coefficient R, we have to use this formula. This is the formula for computing the linear correlation coefficient. It is n multiplied by sigma of xy minus sigma of x multiplied by sigma of y divided by square root of n multiplied by sigma x square minus sigma x all square times n multiplied by sigma y square minus sigma y all square. This is the formula for finding the value of correlation coefficient. Let's have one example for this auto example to find the correlation coefficient for some data. In this example, we construct a scatter plot for the data shown and compute the linear correlation coefficient for the data. We have two requirements. Construct scatter plot. I have x and I have y. So the xy, the first one is 63 and 7. Second one, this is x, this is y. 29 and 3.9. Next one is 20 and 2.1. These are the ordered pairs. 19.1 and 2.8. Next one is 13.4 and 1.4. Next one will be 8.5 and 1.5. These are x and y. So scatter plot will be like this. So it's just dot in the xy plane. This is scatter plot. Just graph these ordered pairs in the xy plane or just in the plane. I have, this is x and this is y. We have something like this one. This is the scatter plot. Now for the second one, which is that I need to find the compute linear correlation. I have x and I have y. If we go back to the formula, we must have xy, we must have sum of x, sum of y, x square, and y square, all of these. So I need to find x multiplied by y first. That will be 63 multiplied by 7 equal to 441. This is the first one. Next one, 29 multiplied by 3.9 equal to 113.1. Next one, 20 multiplied by 2.1 is 42. Next one, 19.1 multiplied by 2.8 equal to 53.48. Next one, 13.4 multiplied by 1.4 is equal to 18.76. Next one, 8.5 multiplied by 1.5 is 12.9. 0.75. Now for x squared, square the x values, 63 square is equal to 3,969. Next one will be 29 square, this is 841. Next one, 20 square is 400. Next one, we have 19.1 square equal to 364.81. Next one, 13.4 square equal to 179.56. And last one, 8.5 square is 72.25. Now for the y square, also we need to square it. First one will give me 49. Next one, I have 3.9 square, that will be 15.21. Next one, I have 2.1 square is 4.41. Next one is 2.8 square, that will be 7.84. Next one is 1.4 square, which is equal to 1.96. And last one is 2.25. Now we need to find the total for each one. Sigma of x, that will be 63 plus 29 plus 20 plus 19.1 plus 13.4 plus 8.5. That is 153. For x, it is 153. For y, 7 plus 3.9 plus 2.1 plus 2.8 plus 1.4 plus 1.5 equal to 18.7. Now, sigma of xy, the sum for this third column, 441 plus 113.1 plus 42 plus 53.48 plus 18.76 plus 12.75, which is equal to 681.09. Now sigma of x squared, that will be 3,969 plus 841 plus 400 plus 364.81 plus 179.56 plus 72.25. That equal to 5,862.62. Next one, sigma of y squared, I have 49 plus 15.21 plus 4.41 plus 7.84 plus 1.96 plus 2.25, which is equal to 80.67. I have all of these values. I can find the coefficient or relation coefficient that are equal to. If you go back to the formula, let's see. I have n there. N equal to number of the ordered pair. It's the number of moments. Let's see how many ordered pairs we have. 1, 2, 3, 4, 5, 6. These are 6 points. 1, 2, 3, 4, 5, 6. So n equal to 6 in this case. So the correlation now coefficient, the correlation coefficient will be, it is n multiplied by sigma of xy. N equal to 6 multiplied by sigma, let me write the formula first. It is n multiplied by sigma xy minus sigma of x multiplied by sigma of y divided by square root of n multiplied by sigma x square minus sigma x all square multiplied by n multiplied by sigma y square minus sigma of y all square, which is equal to 6 multiplied by sigma xy, the first one, it is 153. Sigma of x, it is 153. Sigma of y, well, 18.7. Divided by, come back, it is, then we have square root of 6 multiplied by sigma x square, sigma x square, this is this one now, I'm sorry, first of all, sigma of xy, this is not 153, I use should be the third one, this one, 681.09. Now, sigma x square, to this one there, fourth column, 5862. So this 6 multiplied by 5862.62 minus sigma of x square, that is 153 square, multiplied by 6 multiplied by sigma y square. Y square is this one, which is 80.67 multiplied by 80.67 minus sigma y square. Sigma y is 18.7 square. This will give me now for the numerator. Let's find the numerator first. I have 6 multiplied by 681.09 minus 153 multiplied by 18.7. that it will be 1020 or 225.44 divided by square root of 6 multiplied by 5862.62 minus 153 square multiplied by 6 times 80.67 minus 18.7 square is equal to I have to do it in 2 steps. This will be 6 times 80.67 minus 18.7 square. Divided by 1257.228, which is equal to. So R in this case is equal to I have 1 to 25.44 divided by 125.228, which is equal to, let me divide that, 122.8 point equal to 0.9747. So this is R is equal to 0.9747, which is close to plus 1. It means we have, there is a linear correlation or a linear positive correlation between X and Y. So if R is very close to plus 1, we will say that we have positive linear correlation. If it is close to minus 1, we will have negative linear correlation. And we can see this from the graph. As X is increasing, Y is increasing. See, start with this point. If we move to the right, it means we are increasing the value of X. As we increase the value of X, the values of Y also are increased. So we can see we have positive linear correlation. It is almost linear, and it is positive. Increasing X will increase the values of Y. So this is the idea of or the principle of the correlation coefficient R, just to find the relation between x and y. Is it positive or negative? And how strong it is. If it is very close to 1, we will say it is linear correlation. If it is far from 1, then in that case it is not very strong linear correlation.